Now we take an example to find the base point estimator. Consider the model, that is xi given theta, or the IID from the binomial distribution with parameter 1 and theta. And theta, capital theta, basically it is representing the all the possible densities which belongs to that parameter space for the Poisson distribution, and we consider it as a beta distribution with parameter alpha and beta, and here alpha and beta are known, and the distribution of the prior, you can see that is h of theta, that is given that gamma alpha plus beta over gamma alpha gamma beta, theta raised to power alpha minus 1 into 1 minus theta raised to power beta minus 1, and theta lies between 0 and 1. And we are interested to find the decision function delta, which is a base estimate or base solution. So how we proceed for this one? As we know that y, that is actually sum of xi, is a sufficient statistic which has a binomial distribution with parameter n and theta. We have already proven this part in the sufficient statistic. So it is given as g of y, that is actually the nc y theta raised to power y into 1 minus theta raised to power n minus y, and y varies from 0, 1 to n. The conditional distribution, actually now the conditional distribution, which is actually we are interested to find the posterior distribution, in other words, that is actually k of theta given y in term of proportionality. We can write it as theta raised to power y 1 minus theta raised to power n minus y into theta raised to power alpha minus, that is actually the density of the prior, into 1 minus theta raised to power beta minus 1, and theta varies from 0 to 1. So that is the full actually posterior density. By putting the respective constants, we can find it as theta given y, actually that is gamma n plus alpha plus beta over gamma alpha plus y into gamma n plus beta minus y, theta raised to power alpha plus y minus 1 into 1 minus theta raised to power beta plus n minus y minus 1, and it is 0 less than theta less than 1, and y is from 0, 1 up to n. Hence the posterior density is a beta actually density with the base estimator, that is actually alpha plus y over alpha plus beta plus n. Actually that is actually the mean of the beta distribution. So we take the loss function as a scared loss function, that is L of theta into delta y, that is actually we are considering theta minus delta y square, and the base estimator estimate of theta is the mean of the beta distribution. That is just we have proved this one, so we can say that g of y, that is actually alpha plus y over alpha plus beta plus n. So further we can readjust the Bayes estimator as this one. We just separate some parts of this one, that is actually n over alpha plus beta plus n into alpha over n plus, that is alpha plus beta over alpha plus beta plus n into y over that is actually y over n, and that is alpha over alpha plus beta. So which is the weighted average of the MLE? Which is the weighted average of the MLE? Y over n, this part of theta, and the second part, the mean of the prior PDF, which is this part, that is alpha over alpha plus beta, and the weights are here, that is n over alpha plus beta plus n and alpha plus beta over alpha plus beta plus n. And further we can find for the large n result. So for large n, the Bayes estimate is close to the maximum likelihood estimate of theta and delta y, and it becomes consistent, is a consistent estimator of theta. Thus, in selecting alpha beta, not only the prior mean alpha over alpha plus beta, but some alpha plus beta play an important role relative to the sample size.